Hello, this is the section 4.6 lesson. In chapter 3 we talked about the standard algorithm for doing addition. In this section we're going to talk about the standard algorithm for doing multiplication. We're also going to talk about a couple of different algorithms that you may or may not have seen before. We're going to talk about how they're all related, and we're going to try to explain why the standard algorithm for multiplication works. So let's do a couple of examples to refresh our memory on how to do the standard multiplication algorithm. So let's take this problem of 26 times 8. So to do the standard algorithm, we take 8 times 6, and that gives us 48. We're going to write down the ones digit, which is 8, and then we're going to carry the 4, and then we're going to take 8 times 2, which is 16, add the 4, and we get 20. So there's our answer, 208. All right, let's do a little more complicated problem here where we multiply two-digit numbers. Now let's take 37 times 16. So first we're going to take 6 times 7, which is 42. We write down the ones digit, and then we're going to carry the 4. And then we take 6 times 3, which is 18, and then we add the 4, which is going to be 22. And now in our second row, we're going to put a 0 on the right hand side, and then we're going to take 1 times 7, which is 7, and then 1 times 3, which is 3, and then we're going to add, so we get 295. 592 is our answer. So there's a couple of examples of how to use the standard algorithm. Now some questions we might ask is, why does this work? Number 2, what does each step mean? Why do we have 2 rows below the equal sign, and why do we add? What does that really mean? Number 3, why do we carry? Number 4, why do we put a 0 in the second row of that second example? So we're going to try to answer those questions using ideas that we've already talked about. So to start off with, let's go back to this problem of 26 times 8 or 8 times 26 by the commutative property. It doesn't matter which way we organize them or which way we write them. But now we're going to rewrite this in what we call the expanded form. And by the expanded form, what we mean is we're going to take our 8, just leave it as an 8, but then we're going to write the 26 as 20 plus 6. Now this is an idea that we've used, or similar idea to what we've used before. Specifically what we want to do here is write our number 26 so we have the ones digit all by itself, and then a number here with just the tens digit and a 0. And now the reason we do it like this is so that now we can distribute. So we're going to take 8 times 20 and then plus 8 times 6. So there we've used the distributive property. And so now we can do this multiplication. 8 times 20, this number ends in 0, so this product is going to end in 0. And then we take 8 times 2 to get 16, and then plus 8 times 6, which is 48. So now to do this addition, we can off to the side here use our standard algorithm, 160 plus 48, and then we add the 0 plus 8 is 8, and then 4 and 6 is 10, so 0 and 1 and 208, and so this is our answer, 208. Now that's the same answer that we got using the standard algorithm. We just did this in a little bit different way. So now let's take a look at our expanded form. Here's the work from our expanded form, and let's organize that work a little bit differently. What we have here are, in this step, we've got 2 products, 8 times 20 and 8 times 6. These products are what we call the partial products. So when we organize things, we're going to start off with our problem here, 26 times 8, and we're going to write these partial products below it. Specifically, we're going to start with this one, 8 times 6. So we're going to write 8 times 6 off to the side here. I'm going to put a little arrow here, We do that arithmetic, 8 times 6 is 48. So now we're going to take our second partial product, 8 times 20, and write that off to the side here. And 8 times 20 is 160. And now we're going to add those results together. That's what we did here in this step. And then we just do this arithmetic. There's 8 and 0 and 1 and 208. And so there's our answer. Okay. So we took this expanded form, just kind of rearrange things into this form right here. So this rearranged form is what we call our partial products algorithm. And it looks like this. The first row is we have 8 times 6. We could think of this as we took 8 times 6, wrote that there, wrote our result here. And then the next step is we take 8 times 2, but that 2 is in the tens digit, so it's really a 20. So our second partial product is 8 times 20. We do that arithmetic and we get 160. And then we add those results and we get our answer of 208. So now let's compare this partial products algorithm to our standard algorithm to better understand why we do things in the standard algorithm the way that we do. So first note over here that in this second term, that involved multiplying something that ended in 0. So that means that this partial product is going to end in 0, which means that when we add over here, the ones digit of our sum is going to be the same as the ones digit from the 8 times 6. So that explains why over here when we took 8 times 6, we wrote the 8 down. Now, notice here in the first two digits of our sum is 20. That 20 came from the 4 plus 16. Now, where did the 4 and the 16 come from? Well, the 4 was the tens digit of the 8 times 6, and the 16 really came from the 8 times 2. So that explains what we did over here when we carried a 4. We took 8 times 2 to get 16. Well, that's the same 16 as what we have here. And then we added the 4, which was the tens digit from the 8 times 6. So the point here is that carrying the 4 over here in our standard algorithm is really equivalent to adding the tens digit of the 8 times 6 and then the tens digit of the 8 times 20. So this carrying a 4 over here in the standard algorithm is just really a condensed version of what we did over here in the partial products algorithm. And in fact, that's really all the standard algorithm is. It's a condensed version of the partial products algorithm. We're going to take the steps from over here and combine them into just fewer steps in our standard algorithm. So let's go back to this second problem that we did, the 37 times 16, and look at how we can do that in the expanded form, and then the partial products algorithm, and then the standard algorithm. So in our expanded form here, we're going to take 37 and write it as 30 plus 7. So there we've got the ones digit all by itself, and then kind of the tens digit all by itself. And then likewise write the 16 as 10 plus 6. And so now we can FOIL this out. So we're going to take the first, 30 times 10, then the outer, 30 times 6, and then the inner, 7 times 10, and then the last, 7 times 6. And then in our next step, we're going to just rewrite things a little bit. We're going to take the 7 times 6 and move it up front, and we're going to switch the order of the 6 and the 7, and then we're going to take the 6 times 30, move that here to the second term, rearrange things, and then 10 times 7, we're going to take this term here and move it there, and then we're going to take this first term here and move it here. So all we're doing there is moving things around, and that's all completely justified by the commutative properties of addition and multiplication. So here's the result from our expanded form, what we get after we expanded and rearranged terms. And so here we have 4 partial products, 1, 2, 3, 4. So in our partial products algorithm, we're going to have our 4 partial products here below. So we're going to start off as 6 times 7. That's our first partial product. That's 42. and then we're going to take 6 times 3, but that 3 is in the tens digit, so it's really a 30. So 6 times 30, that's our second partial product, which is 180. Next, we're going to take a 1 times a 7, but that 1 is in the tens digit, so that's really a 10. So that's our third partial product, 10 times 7, which is 70. And then lastly, we're going to take the 1 times the 3, but that 1 is in the tens digit, so it's really a 10. That 3 is in the tens digit, so it's really a 30. And so that's our last partial product, 10 times 3, which is 300. So there's our 4 partial products. Now we're going to add those together to get our final answer of 592. So let's compare this partial products algorithm to our standard algorithm. So here's what we just did, and here's our work from the standard algorithm. And so let's make a couple of observations. First of all, if I were to add the 42 and the 180, I would get 220. Likewise, if I add the 70 and the 300, I would get 370. And so what that illustrates is that these first 2 steps here are condensed to the first step of our standard algorithm. Likewise, these last 2 steps are condensed into the second step of our standard algorithm. Okay. And so note here about the carrying the 4. Where did the 4 come from? Well, we took 6 times 7 to get 42. We wrote down the 2. We wrote down that 2 there because when we add over here, we're going to get a 2 in the ones digit. And then we took 6 times 3, which was 18. Now that's the 18 that we have here. And then we added the 4 there. And so again, carrying that 4 here is really just a condensed version of what we did over here. So let's make another observation about this standard algorithm. As we just noted, this first step here is a condensed version of the first 2 steps of our partial products algorithm, which was 6 times 7 and 6 times 30. If we factor out the 6 from these steps here, we get 6 times 37. Likewise, the second step is a condensed version of the last 2 steps of our partial products algorithm. If we factor out the 10, this becomes 10 times 37. Now, what's important here is that in this second step here, we're multiplying by something that ends in a 0. So because that ends in 0, we're going to have a 0 in the ones digit of that second step. So here's the point here, is that we put a 0 on the right side of the second row in this standard algorithm because we're multiplying by 10, not just a 1. It looks like we're taking a 1 times 7 and then 3, but because that 1 is in the tens digit, it's really a 10, not just a 1. And because that number ends in a 0, that product is going to end in a 0. So that's why we put a 0 there in that second row. Okay, so to kind of summarize what we did here, we talked about these 3 different algorithms, the expanded form, the partial products, and then the standard algorithm. In the expanded form, we rewrote the numbers, broke them up, and then we expanded using the distributive property. The partial products algorithm is we took the work from the expanded form and just kind of organized it differently. Just wrote it kind of vertically rather than horizontally. And then in the standard algorithm, that's just a condensed version of the partial products algorithm. So that's it for the section 4.6 lesson. Your assignment for next class period is to read section 4.6 from the textbook. And in the activities in class, we're going to get more practice using these expanded forms, the partial products algorithm, and relating them all to the standard algorithm.